circuits and circuits. I told you at that time there are two types of circuit. One circuit is called as series circuit, like that. If let's draw three circuits together, and there is a battery. Remember that battery should always be connecting because battery is the one which provides the energy. So if you check this out, if you check through the conventional current, battery is providing the current. Amara, how many path current has in series circuit? Because this is a series circuit.
There's one complete pathway.
And in that one pathway, how many resistance you have it has to pass through it. Okay. So technically speaking, if current I is coming out of the battery, the current I will be passing through resistance R1, current I will be passing through R2, or current I3, current I will be passing through R3. So technically speaking, the total current is equal to the current passing through each resistor. We have written this equation. Did everyone remember that? Ali, Isra, Habib, Amara?
Yes, sir.
Okay.
Yes, sir.
Yes. Then I've told you another very interesting thing. Whenever you're talking about the voltage, remember that voltage is always between 2 points. Can anybody tell me why it's between the 2 points? Why not I'm talking about a complete path? Habib, what do you want to say about it? Ali? Amara? Any idea?
Can you please repeat your question?
My question is why I always say voltage across 2 points. I didn't say, as I said about the current is passing through this path. I didn't say voltage of this path. I say current across 2 points.
Because like the total voltage of the battery is going to be the same
No.
the sum.
You're not understanding my question.
Voltage is between 2 points.
That's why my question is. The reason is very simple. See, because voltage is equal to V is equal to IR as per the Ohm's law. Technically speaking, current is the same in series, but resistance changes. At this point, the resistance is nothing. At this point, the resistance has already passed through R1. So voltage should be between the 2 points, because between these 2 points, V is equal to IR. Voltage is actually due to this resistance. That is the reason why voltage is always across the 2 points, like around R1, across R2, across R3. Okay, do you understand that? Small conceptual thing. Okay, so what is the voltage formula for this? The total voltage or potential difference or EMF will be divided into each resistor voltage. So V1 plus V2 plus V3. Then I told you another very important thing, that in series circuit, you have, let's suppose, 10 resistances connected in series. Remember that these 3 resistance, 4 resistance, 5 resistors connected in series doesn't affect your circuit. The reason is battery doesn't know them individually. Battery can only know the combined effect of it. And that combined effect voltage or resistance is called as R effective. Or we do call it R equivalent. So now the important thing is that we need to find out the formula for R equivalent resistance. Let's suppose if there are 3 resistors connected in series, if I have to replace these 3 resistances, what is the resistance value? That is what we need to find out. Okay. So we can use that formula. V is equal to V1 plus V2 plus V3. Now we know that I is equal to I1 is equal to I2 is equal to I3. So I is equal to IR. V1 is equal to I1 R1. V2 is equal to I2 R2. And this is equal to I3 R3. Since I is equal to I1 is equal to I2 is equal to I3, so you can say that I1 will be replaced by I2 will be replaced by I as well, and I3 can be replaced by I as well. So you can take I as a common, so R1 plus R2 plus R3, and on the other side it's already IR. I and I cancel, so your R is equal to R1 plus R2 plus R3. Did you notice that in series resistance, the combined effect of the resistance will be increased? So basically, if 3 resistances or 4 or 5 or 6 resistances are connected in series, the combined effect can be easily found out by simply adding them. So if you have to replace these 3 resistance, add them, and you can replace a single resistance instead of these 3 resistances. Do you understand that, guys? Amara, Isra, Habib, Ali?
Yes.
Yes, sir.
Please, now what you can do, draw the diagram and write few lines. First of all, draw the diagram. Because this derivation is coming in the examination, so we should do it properly. Let 3 resistances R1, R2, and R3. Let 3 resistance R1, R2, and R3 are connected in series with a battery of V volts. With a battery of V volts. With a battery of V volts. Total current of the battery will be I. Total current of the battery will be I. Current passing through each resistance is I1, I2, I3 respectively. 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 Voltage across each resistance will be voltage across each resistance will be V1, V2 and V3 respectively. V1, V2 and V3 respectively. Since in series circuit, in the next line please, in the series circuit, current has one path to follow to complete the circuit. Current has one path to follow to complete the circuit. Therefore, total current of the battery is equal to current passing through each resistor. Total current of the battery is equal to current passing through each resistor. Write the equation. I is equal to I1 is equal to I2 is equal to I3. Right in the next line, in a series circuit, voltage of a battery, voltage of a battery, voltage of a battery will be equal to voltage across each resistor. Voltage across each resistor, which is V is equal to V1 plus V2 plus V3. Write this equation. Okay, have you write this, guys?
Yes, sir.
Okay, in the next line, just write to find out the R effective or R equivalent. To find out the R effective or R equivalent, which is the combined effect, resistance of a circuit. Just write R effective. Write this from here till here. Also write the front one as well, because this is the indicator I is equal to I1 is equal to I2 is equal to I3, and write till R. But only thing you need to do is to write here R equivalent is equal to R1 plus R2 plus R3. Students, you just copy. Give me 1 minute, please. All right, students, have you copied it? Everybody understood
Yes,
it?
sir.
Hello? Any questions? Ali, Amara, Isra, Habib?
No, sir. It's clear.
Okay. It means that mathematically, if, for example, you got 3 resistances in series like that, if I ask you what is the combined effect of this resistance, that is R1, R2, and R3, that is 2 ohms, that is 3 ohms, that is 5 ohms, that is V is equal to, let's suppose, 12 volts. Now let's ask a question. What is R equivalent for this? What is VI? V1 means V2 and V3. And what is the total current of the battery? Or you can say I1, I2, and I3. This is the question. I want you to copy this question and then listen to me very carefully in this, because from here our calculation work started. Once you copy the question, let me know, please. Yes, guys, have you copied it?
Yes, sir.
All right, students, let's listen first. Remember that whether it's a series circuit, whether it's a parallel circuit, whether it's whatever circuit it is, you have to start the circuitry, you have to start the calculation by finding R equivalent. So what will be the R equivalent in that case, Amara? It means all the 3 resistance can be replaced by a single resistance. What could be the value for that?
Should we add them all?
Yes,
And then,
yeah. So
so
R
it's going to be 10.
So now for make my ease, I'm just giving them name because this is R1 and 2 and 3. So I'm giving it R1, 2, 3. So you add them all, it is equal to 10 ohms. So technically speaking, the first unknown value is found out, which is 10 ohms. Now, second important thing is to find the current. Now, remember that one single resistance and single voltage source is there. Now you can simply find out the total current. What is the formula here? V is equal to IR. So I is equal to V over R. So voltage is 12, resistance is 10, value is 1.2 amperes. This is the total current of a battery, which means that your current value can never be more than 1.2 in the circuit, because the battery is giving 1.2 ampere of the total current. Ali, can you tell me what are the values for I1, I2, and I3?
You divide the amperes by 3.
No. In series circuit, the first line which I have just written was that I, that is the total current, is equal to I1, is equal to I2, and is equal to I3. It's the same current passing through each resistor. So I1 value, I2 value, I3 value, total current value will be same for each and every resistor. Current value will be same for everyone. Now voltage is very simple. V1 is equal to I1 R1, V2 is equal to I2 R2, V3 is equal to I3 R3. Simply put the value in this. I is equal to 1.2, R1 is 2. Here, I2 is same 1.2, R2 is 3. And here, it's 1.2 multiplied by 5. Can you tell me the value for each? It's 2.4 volts. That's 3.6 volts. And the last one is 6 volts, right? Interesting fact is, if you add them all, it will give you 12. So if it's not giving you the total, it means you've done something wrong.